Ohm's law, Kirchoff's voltage law, KVL, and Kirchoff's current law, KCL, are fundamental principles in electrical circuit analysis. Let's understand each of these laws. 1. Ohm's law. Ohm's law states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points, and inversely proportional to the resistance of the conductor. 1. Mathematically, it can be expressed as V equals IR, where V represents voltage, in volts, I represents current, in amperes, and R represents resistance, in ohms. Ohm's law allows you to calculate one of the three variables, voltage, current, or resistance, if you know the values of the other two. 1. Kirchoff's voltage law, KVL. KVL states that the sum of the voltages around any closed loop in an electrical circuit is 0. 1. It is based on the principle of conservation of energy. 1. According to KVL, the algebraic sum of the voltage rises and voltage drops across any closed loop in a circuit must equal 0. KVL is commonly used to analyze complex circuits with multiple resistors, voltage sources, and current sources. It allows you to determine the voltage drops across different elements in the circuit. 1. Kirchoff's current law, KCL. KCL states that the sum of currents entering any node, junction, in an electrical circuit is equal to the sum of currents leaving that node. 1. In other words, the total current entering a node must equal the total current leaving the node. 1. KCL is based on the principle of charge conservation. KCL is widely used to analyze circuits and determine unknown currents at different nodes. It helps in understanding current flow and current distribution within a circuit. Both KVL and KCL are essential for analyzing complex circuits and solving circuit equations. They provide a systematic approach to understanding and predicting circuit behavior. These fundamental laws serve as the basis for circuit analysis and are widely used in electrical engineering, electronics, and various fields involving electrical systems. They enable engineers and technicians to design, troubleshoot, and optimize electrical circuits.